Okay, so we're going to look at the first and second derivatives in graphical analysis with the titration curve data that you guys have. So if you look at this is what your titration curve should probably look like at the moment, just with pH versus milliliters of NaOH added. And what we're going to do is we're going to take the first and second derivative of it to give us a better estimate of the equivalence point. So right now, if I'm looking at this graph, my equivalence point, right, is we're looking at this big jump, and it's about halfway in between the jump, which is tough to eyeball. But I mean, you could kind of connect it and then measure and then pull down. So it's somewhere here, maybe 1.7-ish, right? That's kind of what I would look at here, like halfway between here coming down. Maybe you guys would say 1.6. Okay. All right. So I'm going to continue this on so you guys can see. So if we look here, now we're going to click on these three dots up here next to the pH, and we're going to add a calculated column. So click on that, add a calculated column, and you're going to title it first derivative. And then you're going to insert expression and find the one that says first derivative. And just check that it's plotting pH versus milliliters of titrant, and yours probably just says milliliters of NaOH added, and hit apply. And so this is the first derivative. So what we get from this is that point where there's a jump, it correlates with this high point right here. So if we bring this down, does that kind of look like where we were before? To me, it looks like where I was guessing. It looks like it's a little to the right of that, which again, this is a more accurate measurement. And the second derivative is even more accurate than that. So we're going to look at that in a second. But so this gets us a little closer. So maybe even closer to what I was thinking, like 1.7. So now we're going to add the second derivative. So you're going to go back to the pH three dots again. And we're going to make it second derivative. pH, exactly. pH, added calculated column. And we're going to call it second derivative. And then we're going to insert expression. And again, check to make sure it's pH versus milliliters of NaOH added. And apply. So now it's going to look a little different. You have to click on the axis over here and click second derivative and click off first derivative. Okay, so now it looks like this. So what we're looking on the second derivative, we're looking at the inflection point. The inflection point where it crosses the x-axis is where we're going to have our equivalence point. So it's harder to see because it's not connected, but imagine if there was a line connecting all this, like where would it cross the x-axis? It looks like right here, which is pretty much where we were saying before, right? So that's another value. So I want you to make sure you print a copy of each of these with your lab. So you should have the regular titration curve, the first derivative, and the second derivative for each of your acids, for the weak acid and the strong acid. And just paying close attention to those points that we told you about, like endpoint, equivalence point, and calculating all the different things in the post-lab questions.